Hi, Math 2 Enhanced. This is page 11 of our packet, and it's the synthetic division homework. So let's take a look at number 1. Number 1, it says to use synthetic division, divide the following, and I'll talk about writing our answer in just a moment. So number 1a says to divide x cubed plus 2x squared minus x minus 2 by x plus 2. So I have to think about the root that x plus 2, the factor, gives me, and that's x equals negative 2. So negative 2 is what I'm going to use for my synthetic division. And then my coefficients, and remember you have to go in order. So this is an x cubed, an x squared, an x to the first, and a constant. So I have nothing missing. I don't need to add any placeholder zeros. So I have a coefficient of 1, a coefficient of 2, a coefficient of negative 1, and a coefficient of negative 2. And so I'm going to get ready to start my synthetic division. I bring the first number down. Now I multiply 1 times my negative 2, and I get negative 2. Now I add, and 2 minus 2 is going to give me 0. 0 times negative 2 is 0. And now I add, and I get negative 1. And negative 1 times negative 2 is positive 2. And I add, and I get a remainder of 0. So this is my remainder, and it's 0. So now I know my answer, my quotient, is 1 degree less than my dividend was. And my dividend was an x cubed. So I know my quotient, my answer starts with an x squared. So it's 1x squared, no x term, so 0x, minus 1, which is really x squared minus 1. This is my answer when I do my division. So for B, it asks, what is p of negative 2? In other words, if I took the time to substitute in negative 2 everywhere I have an x in my original equation, what would my answer be? And I don't need to do that math because I happen to know that synthetic division is also known as synthetic substitution, and my answer would be my remainder. That's 0. That's my remainder theorem. My remainder theorem tells me that when I substitute my divisor into my polynomial, what I get is whatever I get for my remainder from synthetic division. So then C says, is it a factor? And yes, x plus 2 is a factor. And that's because my remainder was 0. Now, it says here to write your answer as your original polynomial equals your divisor times your quotient plus your remainder. So what I would write here then is my original polynomial, x cubed plus 2x squared minus x minus 2 is equal to my divisor, which is x plus 2, times my quotient, which is x squared minus 1. Now, I know my x squared minus 1 isn't fully factored. This is my nice friendly dots, my difference of two squares. So technically, this polynomial factors into x plus 2 times x minus 1 times x plus 1. So this is then what x cubed plus 2x squared minus x minus 2 breaks down into. So let's take a look at number 2. So number 2 says to divide this by x plus 2. So when I solve this, I would get x equals negative 2. So negative 2 is going to go into my synthetic division. Now be careful, there's no x squared term. So I need to remember to put a 0 placeholder in for that coefficient. So I have a 2x to the 4th, I have a 6x cubed, a 0x squared, a negative 5x, and a negative 10. So let's do this. I get 2 times negative 2, or negative 4. When I add them, I get 2. 2 times negative 2 is negative 4 again. I get negative 4. Negative 4 times negative 2 is 8. I get 3. 3 times negative 2 is negative 6. and I get a remainder then of negative 16. Okay, that's my remainder. So this is A, by the way, I'm doing the division. So my quotient, my answer then is 1 degree less than my original polynomial. So it's going to be an x cubed. So it's going to be a 2x cubed plus 2x squared minus 4x plus 3 with a remainder of 16, and it's a negative 16. So I'm going to write this as plus negative 16 over my divisor of x plus 2. So then this is my answer after I do my division. So B, what is the answer when I substitute negative 2 into my polynomial? Well, the answer when I substitute it in will be whatever my remainder is, which is negative 16. So is x plus 2 a factor? No, since the remainder is negative 16 or equals negative 16, it is not a factor. It wasn't 0. So let's take a look at 3. So now it wants me to divide by x minus 8, that factor. So that would give me x equals 8 as my root. So I'm going to do my synthetic division with 8. And my coefficients, I've got an x cubed, an x squared, an x, and a constant. Nothing's missing. So I'm going to use my coefficients of 1, negative 22, 157, and negative 360. So I'm going to bring down my 1, and 8 times 1 is positive 8. Positive 8 and negative 22, I get a negative 14. Subtract them and keep the sign of the larger. And then 8 times negative 14, and I would get a negative 112. And then 157 minus 112 is 45. And 8 times 45, grab those calculators, and you should get positive 360. So I have a remainder of 0. And my answer then is 1 degree less than my original polynomial, so it's x squared. So I have 1x squared minus 14x plus 45. And then for B, it asks me what P of 8 is. So if I took the time to substitute 8 into here and do all of my math, I know that I would get a 0 for my answer. That's my remainder theorem. And then it says, is x minus 8 a factor? So yes, x minus 8 is a factor. That's because my remainder was 0. And then lastly, I would like to write my polynomial x cubed minus 22x squared plus 157x minus 360 as the product of my factor x minus 8 times my quotient x squared minus 14x plus 45. And then actually I want to point out that my x squared minus 14x plus 45 actually factors. If I did the diamond method with the 45 at the top and the negative 14 at the bottom, I would get negative 9, negative 5 as my side numbers, and my a is 1. So this is equal to x minus 8 times x minus 9 times x minus 5, if I fully factor that now. And you can do number 4 on your own. Check your answers in our folder. I believe it has the remainder, and I think you're going to get a remainder of 1. And so B would be 1, and then C would be no, it's not a factor. So give that one a try if you haven't already. Thank you.